Hello everyone, we're going to get started here in just a few seconds, so we're going to make sure everybody's still filing in to the webinar, but we're going to get started here. Okay, welcome to Thursday everyone. You know, June is Skyscraper Month, and while I don't think we're going to be talking about skyscrapers today, we are going to get up to speed on something that would affect them, the 2018 IECC. We've got a new guest to the webinar series and a longtime sponsor to help us out. The 2018 IECC has been out there for a while. You know, some states are currently evaluating it for their own respective codes, but today we're going to dig into the residential and commercial codes a little. We're going to discuss some key amendments and compliance paths, but we're also going to go a step further. We're going to look at some field findings and as well as some ways to help meet the duct leakage, envelope tightness, foundation, insulation, lighting, and fenestration requirements. Making her webinar series debut today is Shaunna Mozingo. She works for Colorado Code Consulting and has a number of responsibilities there. Shaunna manages their energy code contracts. She conducts research and provides training to code officials, builders, energy raters, designers, both at the local level and around the U.S. She's also a plans analyst and inspector for many jurisdictions. Now, Shaunna has received a number of accolades, including the Department of Energy's Jeffrey A. Johnson Award for Excellence in the Advancement of Building Energy Codes and Performance, IMT and ICC's Standard Bearers Award for her efforts in compliance with energy codes, and the Southwest Energy Efficiency Project's Award for Leadership in Energy Codes. Shaunna is a past president of the Colorado chapter of IECC and serves on the chapter's education, legislative, code development, and membership committees. She was appointed to the International Code Council's Commercial Energy Code Development Committee and Code Correlation Committee for the 2018 and 2021 code cycles. So in other words, we're talking to someone who is there for every grueling minute of the development of the 2018 commercial IECC. But never fear. We're not going to have any grueling minutes here. This is going to be an interesting and insightful conversation. But before the fun can begin, I need you to sit tight because I have to tell you about PowerShift by NV Energy. You can never save too much energy or money. That's why NV Energy has introduced PowerShift to help its residential and business customers conserve even more energy and save money on their power bills. PowerShift by NV Energy is all about providing you with excellent customer service. It's your one-stop shop to find all the energy-efficient products and services to help you boost your bottom line, along with convenient ways to manage your account. PowerShift Energy Advisors are dedicated to working side by side with business customers to discuss their needs and to find energy efficiency solutions that save money. Plus, their Business Solutions Center is the place to go to discuss your bill payments and account-related questions. For more information, please visit nvenergy.com/PowerShift. Now, during the course of today's presentation, you can submit questions for our guest. Simply use that questions box that's probably on the right side of your screen. I'm going to review those questions, and I'm going to pose those to Shaunna during the Q&A time set aside after her presentation. Shaunna, welcome to the webinar series.
Thank you so much. I'm excited to be here. I will tell you that it is really hard to fit commercial and residential all into an hour, but we're going to do the best that we possibly can and at least get you the highlights of what's going on in the 2018. We're going to start right off with the residential provisions of the code. And the first thing that I like to mention to everybody is this new provision that came in under the 2018 that allows log homes to be exempt from the envelope requirements as long as they comply with IECC 400. So that's new to the 2018. First thing I want to talk about really is what are the paths through the code. A lot of people open the book and they see that first table, the prescriptive R value table, and they think, oh my goodness, this is what I have to do. And I'm just here to say, no, that's not what you have to do. That's one option. And so I want to talk to you a little bit about all of the options in the code so that we have a little bit more understanding of how to use it. There is, of course, that prescriptive code. Just tell me what I have to do, and that's what I'll do. You can use that. There's an R value table that you can use that's set up. So, you know, if, for instance, you're in climate zone 2, you have to do everything in that column. You have all of your building assemblies across the top that you have to comply with, and then you just go through and say, and you know, you have to do a 0.40 U factor for your windows, a 0.65 for your skylights, and so you just go across and do that. There was no changes from the 15 to the 18 for climate zone 2 in that table for R values. Now there was a change for some of the footnotes, and so we will look at those in just a few minutes. Now if you're in climate zone 5, there was a change in a couple of things, mostly the U factor. The U factor used to be 0.32 for windows, and now it's 0.30, but everything else stayed the same. So the big change is that footnote D down there at the bottom, where we used to have to deal with this with the slab edge insulation on our foundations. This applies to both commercial and residential. The change took place where it says you have to put an R10 in climate zone 5. If you're 4 through 8, you have to do this R10 insulation on the edge of your slab to protect that slab edge. And then if you heat the slab, you are supposed to add an extra R5. But the mechanical code always required that if you had a radiant slab, you had to put an extra R5 under the entire slab, and that wasn't ever in the energy code. So now what we did was took that requirement out of the mechanical code and brought over into the energy code, so that now it says if you heat your slab, you put the R5 under the entire slab, and then you don't have to add the extra R5 to the side of the slab in addition to it. So that's a change that's a change to the code because of there was always either a conflict or just a lack of correlation between the two codes. So just put it all in one code. So that is one change in that table that it will affect. So you have this prescriptive R value table, this book by the book approach. Let's just look at it real quick. If I'm in, say, climate zone 5, for instance, I'm just throwing out climate zones there, but if I'm in climate zone 5, for instance, and I have to put R20 in the wall, well, what if I want to do an R19? Can I still do that prescriptively without jumping through a bunch of hoops? Yeah, you can. You just need to turn the page in the code book. You just can't use this table. So I could go to the next page in the code book and use this table, right? So this is the assembly R value. I would just need to get a 0.06 for my assembly, and then I could still comply prescriptively. Well, how do I get a 0.06? Well, R value for this table, R value is just the value for the insulation. So in R20, you have to put in an R20 insulation. You don't get to count air film and drywall and all of that to get to your R20. You have to put in an R20. But on this table, you count every layer of your assembly. So I can add my drywall, I can add my air film, I can add my framing and everything, and I just need to stay to that 0.06 for my insulation. R is 1 over U, so you could see the difference. If I had an R20, that would equal out to a 0.05 U factor. Well, it says I have to stay under 0.06, and that's because I have my U factor is going to add into the sheathing and the air film and everything else that I'm putting into that wall. So it's more than just the R20 that I'm putting in there. So you just want to add up all those layers. You can go to ASHRAE Handbook of Fundamentals. You can go to ASHRAE 90.1. You can go to Res Check. There are many ways to find out the different U factors for all your framing materials so that you could add it up. But why would you when you can use this path? This is your total UA path. Instead of just using this table for that one assembly, the total UA path says, let's do the calculation for the entire building. Right? That's the total UA path. It's keeping your U factor and your R value paths equal, and it's adding up the sum of the U factors for all of the building. This is saying, you know, I think of this path as my checking account path. What this is allowing me to do is trade off anything that can be converted to a U factor. So maybe if I put in better framing, or framing has some U factor, windows, anything that has U factor, installation, glass, those sorts of things. I have this checking account. Anything I do better than code makes a deposit into my checking account. Anything I do worse than code makes a withdrawal from my checking account. I just have to keep the checking account in the black. So I can do worse than code in some areas. Maybe I don't want to do slab edge insulation. I will put in a better window, or I'll put in better insulation, or I'll put in less wood, do advanced framing. I'll do something. Continuous insulation always gives me a better credit than cavity insulation, so I'll do continuous. What are you willing to do better than code to do less than code somewhere else? That's this path. So you look at these buildings, you know, if structurally you think, oh, I have one king stud, that's really good. Well, what if I have two? That's got to be better. Well, what if I have six? And I'm really doing good. What if I have 15? I mean, I'm building structurally sound now. Well, I guess that's questionable, but your building is not going to perform. Look at all that wood. Wood has about 1 R value per inch, whereas insulation is anywhere 3.5 to 7, and even getting better than 7 these days. So you could see in this house where I can see all of the framing. So I'm letting a lot of thermal loss out at all of this wood because it only has 1 R value per inch. So what you can see the thermal loss coming through there. So what if I did less wood? There's a great thing on reducing thermal bridging on Building American Solutions Center, and talking about if I do advanced framing where I do 24 inches on center instead of 16 inches on center, then I am reducing the thermal bridging in this wall. I have less wood, so I've just made that U factor better for that wall. So one way to trade off out of something is to do advanced framing. Use less wood, more insulation. You could probably drop down on the R value of insulation because you're using more of it and you're using less wood. So that's one way to possibly make a trade. If you do continuous insulation, you can make a lot of trade because that gives you really good credit towards your U factor of your whole assembly. Or what if I put in a really good window? If the code says I have to put in a 0.30 or a 0.35 and I put in this 0.21, I mean, that's going to get me some great trade. But how do I do all these calculations? Well, you don't. You let somebody else do it for you, right? So the Department of Energy has this free software program, ResCheck, that many of you are familiar with. So you use ResCheck to get out of this to do your trades and to do the calculations for you. It's a free software program that you download at energycodes.gov to get you that trade. You just click on ResCheck and download it. It's all drop-down menus, and you tell it what you're building, and it will calculate it for you and let you know if you pass or fail. And it allows you to do some things less than code by doing some things better than code, as long as in the end you pass. So that's another option in the code. A lot of you familiar with that. But what about this performance-based compliance? The simulated performance path of R405. That's looking at the whole house as a system, using the whole, every system in the house, the lighting, the mechanical, the envelope, looking at all of them. It does look at trading off R values and U factors, but it also looks at trading off air infiltration and exfiltration. It looks at how energy moves in your building and how things work. You know, I can do high efficient lighting. I can do better duct leakage. I could do better envelope leakage. There's a lot of things that I can look at now. I'm looking at the whole house as one big system, not just the envelope like the other paths allowed. It requires a computer modeling software to look at these houses side by side. So I call it my twin house comparison. So the modeling software is looking at two houses side by side, same climate zone, same square footage, same window area, and where am I building it, what way is it facing, and then it says, okay, it's going to compare this house built strictly to the 2018 code and to the prescriptive path, and then whatever the builder wants. So the builder decides, or designer or owner decides they want to do this, not what the code says, but I want to do this. It's going to compare them side by side. And instead of comparing U factor to U factor, it's comparing how much each house costs in energy every year. So it's based on cost, and it's going to look, as long as the way you want to build it will cost equal to or less than the way the other house built strictly to the prescriptive requirement, as long as it's, you know, you can keep that cost down and show that the way you want to build it will be less than or equal to If you built it to code, you're fine and you pass. It does require modeling software. There's a few of them out there. Energy gauge is commonly used in like Florida, but you have REM rate software that has been used for a while. Ecotrope is on the climb now. I see a lot more people using Ecotrope. There's different softwares out there. The code will not require a certain software. It just requires that the software do certain things so that we're not getting into a proprietary fight out there. A lot of these software programs require certified users for them, so sometimes you find that you now have raters, energy raters doing this because they're the ones getting certified to use this software and be able to do this. So that's one pathway. It's based on cost. There's another pathway that came into the 15 and got a little bit modified in the 18. This is that ERI, Energy Rating Index Path. Some people refer to as the HERS score path. The code can't say HERS score because HERS is proprietary. So it's an Energy Rating Index Path. It's using the same software, the same raters, the same, looking at almost everything the same. It's just on this one you use a score to show compliance instead of cost. And so the scores are based on 100 is a house that just meets the 2006 energy code. That's when we started. We changed the way the scoring system works. So in 2006, a score of 100 was just meeting the prescriptive requirements of that. So if this 9 was 15% better than the 2009 was 15% better than the 06, you'd get a score of 85. If, and so we're up to 2018. What is that score? Probably somewhere between 63 and 65 maybe would be a score, 65-ish would be the score to just meet the 2018. So you just need to meet that score, although this compliance path makes you meet a certain score. It does require that you do the mandatory requirements of the code, and you can never build your envelope worse than what was in the 2009. There's a backstop in there because this path brought in a lot more trades that you can use than any other path in the code. And because there's so much trades, wanted to make sure you still built a really good envelope before you went messing around trading things off. So if you look at the 2009 versus the 2018, the 2009 is in black. The 2018, you can see if you were in climate zone 2, you used to be required a 0.65 window U factor. Now you're at 0.40. So you could still trade off, but you could never go worse than 0.65. And so in your ceiling insulation, you can never go worse than 0.3 or R30. Can never build worse than a 2009 house because you're getting to trade off a lot. So it's again that same twin house concept, just a little bit looking at it a little differently in that the score is based on the 06 prescriptive requirements, but you have to build to the 09 mandatory at a minimum, and then there's the envelope values, and then you have to do the 2018 mandatory requirements, blower door tests, lighting controls, your mechanical sizing, and those kind of things. So you still have to do all of those. So if you build this house here, it has to get a certain score in order to show compliance, and it's on that energy rating index. So that score is set. In the 15, the scores were much lower. They actually raised them because these scores were not equal to any of the other paths. And so now you can see if I'm in climate zone 5, I have to get a score of 61. That seems still a little bit lower than if I were in any of the other paths, because I just said earlier that a 2018 would be about a score of 63 to 65. Why do I have to get a 61? Because there's a lot more trade-offs. I could put in a high efficiency piece of mechanical equipment to lower my score. There's no other path that I can do that. That went out of all other paths in the past, but it came back in under this path. So it's going to require me to get a little bit less of a score. I can use solar. I can do some things to lower my score that I can't get credit for in other paths. So I have to get a little bit better score. Another change that came into the 2018 was there was this big dispute over was the 2009 building envelope strong enough if I were going to go put solar on the house to lower the score. I could lower my score all the way to 50 just by putting some solar on there. And is that okay even with just a 2009? It was a big to-do, but in the end, the parties that be kind of sang kumbaya, the solar, everybody got together. It was a big thing and came up with this new footnote that says, okay, if I'm gonna use solar, my envelope has to meet the requirements of the 2015 instead of the 2009. So if you're not using solar to lower your score, it doesn't say you can't use solar. It's just saying if you're going to use it to lower your score, you have to build the envelope to the 15. But if you're not going to use it, you can build the envelope to the 2009. So some things that can lower your score: high efficiency equipment. You know, right now the 2018 says 75% of your lights have to be high efficacy. You could put in 100% and get some credit for that. Put in some solar. Put in ducts all in conditioned space instead of in unconditioned space. You'll get credit for that. If you know, duct leakage, make your ducts tighter than they were supposed to be, and you'll get credit for that. If you build tighter than 3 ACH in climate zone 5 or 5 ACH in climate zone 2, then you could get credit for that. So there's some things you can get credit for in that path to trade off. So those are basically your paths of compliance. Let's talk about those mandatory things, the things you can't trade off. You know, it's mandatory that you build a tight house, right? Well, if you're going to build a tight house, you better bring in ventilation, but we'll get to that. So building a tight house, why? Why do we care? Why do we care about air movement? Well, when air moves in your house, it brings with it a lot of things. Anything that's outside makes it into your house, right? So right now we have a lot of wildfires burning in Colorado. I have a leaky house. I get to experience the wildfires inside my house and outside, right? Or if there's any kind of allergens or anything floating around out there, I get it. Or any kind of what else is the air carrying with it? Moisture. If there's moisture outside, I get to have that moisture now inside my wall assemblies. Or I'm in Colorado, I'm in a very dry climate. I have more moisture on the inside of my house. So if I have a leaky envelope, the moisture inside of my house is getting into those wall assemblies from the inside. So there's all kinds of reasons. We also, you know, we don't want to make people sick. We don't want our assemblies to degrade. We want to be durable. We want to be healthy. We want to be safe. And we also want some predictability. If I have a lot of air leaking out of my house, then now I have to constantly reheat the new air that's coming in, because what goes out must come in, right? So if the house is always going to try to keep itself pressurized, so whatever air goes out makes new air come in. So I'm going to constantly be reheating and recooling new air all of the time and dealing with whatever new air brings with it all of the time. So these are just some things that we think about when we say let's build a tight house. And so how do we do that? We require blower doors. It's mandatory that you do blower doors. It's been mandatory since 2012. The rates haven't changed. So if you're in climate zones 1 and 2, you're at 5 ACH 50. In climate zones 3 through 8, 3 ACH 50. It's not hard to do with today's building materials. The concept here is we put this blower door, we put this big fan in the door and suck all of the air out. And if you build leaky, a bunch of air is coming in. But if you build tight, then not so much. We're trying to get to not so much so that we can save our envelope assemblies, save the people inside the building, and more efficiently heat and cool that air inside the building. And so we're trying to get that down to not as much. So how do I do that? You know, you say, I got to be at 3 ACH 50. What if I don't get there? Well, we gave you a roadmap to get there. So there's two tables, and if you're familiar with the 9 or the 12, there was one table that talked about here's all your components that you have to seal and insulate, and here's how you do it. In the 15 and the 18, we just broke it out and said here's the assemblies, here's where your air seal it, and here's the insulation requirements, so that it's just easier to read, but the requirements are exactly the same. But it's mandatory. You do everything in this table, you will get to your air tightness. You won't fail your blower door. You won't run into those problems. And so, of course, it says you have to comply with manufacturer's install instructions for everything. I'm not going to go through everything in the table because it's just, you can't do that in an hour and try to cover residential and commercial. So, but I'll just, it's laid out like this. Each section, make sure you have a continuous air barrier, seal everything up, don't use permeable insulation to seal it. It talks about your ceilings, it goes all the way down the building, it talks about your walls, making sure you know that your insulation must be in contact and alignment with its air barrier, right? And that you get some insulation in the headers and the corners, and how to seal everything up. If you do all of this, you will get to your 3 and 5 ACH that's required. Not a problem. I've gone into jurisdictions that are on the 2006 code that want to go to the 18, but they're freaking out about these blower door requirements and this air tightness and how much money it's going to cost and what it's going to do. And guess what? They're already there. I said, let me come do blower doors for you for free in your houses, and we're going to find one of two things. Either you're already there and you just don't know it. It's not based on the code that you're on. It's based on the materials you're using, your construction practices. So you're either there and you don't know it, and you're probably not providing good ventilation, or you're not there and we have some education to do, but it's not going to be hard. And every single one of them came in under 3 air changes per hour on a jurisdiction that was under the 06 code, because we're using different materials. You're building tight, you need to make sure you're getting some ventilation in there. A lot of jurisdictions amend blower doors out of the code, and I say that's fine if you're going to do that, okay, but I just want you to know that you still need to make sure they provide ventilation because they are building tight. Some new things that came into the 2018 for ducts. You've always been required to seal your ducts. You have to seal them. There's many reasons. The leaky ducts change the way air moves in the house. If I overpressurize one section of the house and underpressurize, I make force air out and suck air in, and it changes things, and I run the risk of getting that moisture and stuff into my assemblies. It also makes the furnace work harder to keep the room at the same temperature. So those kind of things that we've always dealt with. Those haven't changed. You have to test them if they're in unconditioned space. And that hasn't changed since the 15th. What did change is these new sections that the National Association of Home Builders brought in to the 2018 about buried ducts. So a lot of times, if you want to put a duct in an attic, you had to put it on top of the insulation to make sure it stayed on top of the insulation, because if you put it inside the insulation or laid it right on top of the ceiling and put your insulation over it, your insulation wasn't in contact with its air barrier. You weren't getting the full insulation value in that cavity between those trusses. And so you were having to keep the insulation above, or keep the duct above the insulation. So how can I put my duct in the cavity and still meet the requirements? So, or how can I have my ducts be considered to be inside the conditioned space even if they're in the attic? These are things that these new sections are dealing with. You can put your duct in there, but you better put a certain amount of insulation on the duct, and you have to have a certain amount of insulation below the duct and a certain amount of insulation above the duct. There's some very specifics if you want to call it an in-conditioned space and still meet your duct insulation requirements and still meet your ceiling insulation requirements. A good article that Joe Stiebert did on this very situation, trying to deal with the sweating of the ducts up in an attic, at buildingscience.com. You can look up this article called No Sweat. He did a good article on that for talking about how to do this. And then the other thing that came in new to the 2018 is just this lighting. A minimum 90% of the lamps have to be high efficacy. It used to be 75. In the 2009 it was 50. I don't know if it'll ever go to 100, but we're at 90% have to be high efficacy. So those are your major changes for residential. In commercial, you still have your same paths. There was no addition of new paths. You have the option to go with ASHRAE 90.1 instead of the energy code, or you can go the energy code with its prescriptive paths, which include the ComCheck path and the R value table, the U factor table. So we'll look at that. If you choose the prescriptive path, you also still have to choose one of those additional efficiency package options, just like you had to in the 15 and the 12. Or you can go performance. So keeping in mind the ASHRAE 90.1 was more efficient than the IECC. So in order to be able to be considered still a commercial code that was recognized by the Department of Energy, we needed to make a jump in the IECC to try to keep up with ASHRAE 90.1. So we had to make about a 15% jump in the 2012, which we did. We could have done that by cranking down all of these systems, envelope, mechanical, surface water heating, and lighting by 15%, but we didn't, because the code says we need to keep flexibility, and when you're trying to crank things down that much, it's hard to be flexible. So in keeping with flexibility, we cranked these down a little and then gave you the choices of how you get the rest of the way, or the designers or the builders, how to get the rest of the way. They had to choose the options. In the 2012, there were 3 options. You either did more higher efficiency mechanical, higher efficiency lighting, or renewables. In the 2015, you had 6 options. And now in the 2018, you have 8 options. So you can either do better watts per square foot on your lighting, or 10% more efficient on your mechanical than the code would require in 403, or you can do some enhanced lighting controls. These were all in the 2015, or a dedicated outdoor air system, which is great. This is handling your ventilation air separate from your heating and cooling, and also deals with moisture in the air. Very efficient. In fact, I thought it was going to be a requirement in the 18, but it didn't pass the final vote. You could, if you're a occupancy that uses a lot of hot water, you could do some more efficient water heating, or you could do your on-site renewables. But new, you could do a blower door test, or you could do a total UA that's like get your ComCheck to pass by 15% better than code, right? That's a really layman's way of saying that, but that's that's not the only way you could do it. You could take that total UA, that U factor table in the code that we're going to look at in a second, and calculate the U factor for that whole area of your building and be 15% better than code instead of just doing it right out of the thing. So that's what it would really require. So you have more options in the 18. So I think it's great that we're bringing in more options. All right, so here's that prescriptive table. If you're in climate zone 2, you just look at this column. This R column is for all your R1s, and any of your R2s, 3s, and 4s over 3 stories. Because your R2s, 3s, and 4s under 3 stories are out of the residential chapter. So you would use that for the R. Everything else is over here. It's broken down by roof, walls above grade, below grade, floors, slabs. So it's still the same. Not a ton of changes, really. In fact, there's some bars in here that I am not even sure what they go to because I looked, like, for instance, on here, there's a bar here, but I've compared this 2 or 3 times to the 15 and the 18, and I haven't found a single difference in there. I don't know if that bar got left in there. This bar here, there is a change. So the whole table didn't really change at all, except for this change of that, if you heat your slab, you put the R5 under the whole slab. That's the only major change that you're going to see. So I just keep highlighting climate zone 2 and 5. There's other climate zones, but and so that's the only major change in that table. That's that bar. I can't figure out what changed. So here's the U factor table. Now some of the U factor tables, the U factors did change, but that's just simply because every code cycle we argue about the total assembly and, should it be 0.080 or should it be 0.081 or should it be and so the powers that be nitpick those U factors apart, and so sometimes they change even though the other table didn't change. So there's not a lot of change there when it comes to that table. So what about ComCheck? Where does ComCheck fit into all of this? There is a section in the code called Component Performance Alternative that is as close as you're going to probably get right now to being what's behind the scenes in ComCheck. So this is really the path for ComCheck. It's really not a total UA path in the commercial section, but there is this path, this component performance alternative. This doesn't mean you're going performance. It means it's an alternative to performance. So it's whatever you can convert to a U, F, and C factor can be traded off, just like in ResCheck. So keep in mind that the trade-offs are only in the envelope. The mechanical and the lighting are included in ComCheck, but they're just compliance reports. But you can't trade within them. You can't do better lighting or better mechanical to get out of anything, and you can't get out of envelope by doing better in those other two. Those are just compliance reports. The trade, the checking account is only in the envelope. And that hasn't changed. This is new to the 2018. So there are people who say, well, you know, it's always been, you can count layers of insulation and you count your layers of your assembly based on if everything is stacked on top of each other and you don't really have an airspace in there. That air, once you get air moving through your assembly, it lowers your U factor. Well, but there are times when air in an assembly can raise your U factor, and you can count it as some R value. I mean, R value. And so there are times when you can count that air as part of your R value. The only way that you can count layers of your assembly with an airspace in it is if you completely enclose that airspace. So yeah, there's air in it, but there's no air moving, right? So it used to be, so somebody would say, okay, well, let's say I have continuous insulation on the outside of my assembly and continuous insulation on the inside of my assembly. But I'll have, the two insulations are not touching each other. There's an airspace between them. You could never count the two together. You can't add up the two layers to meet your requirement because there was an airspace between them. This is saying, well, as long as everything is fully enclosed, and it gives you a lot of things about the rate at which air can move through there. There's some technical terms I don't put that up here, but it gives you provisions to be able to count an airspace if you want to get that technical into your assemblies. The main change for U factors for the windows is really in these climate zones really was there was really no change in climate zone 2 for U factor, but it did raise the solar heat gain that was allowed in climate zone 4. So in climate zone 4, we used to only be allowed 0.36 U factor. Now we're at 0.38. They said that it went too low in the 15, so they put it back up in the 18 for climate zone 5. So that's this bar. Some of these other changes in the higher climate zones found solar heat gain requirements come in where they weren't required before. Ours got raised in climate zone 5 here in Colorado. No real change in some of these other ones. All right, let's look a little bit at mechanical. Really, so the only real change here is that it used to say that mechanical systems couldn't be sized to exceed the load. Well, if I did a load calculation and it said I came up to 187,000 BTUs, doesn't mean I can go out and buy a piece of equipment that is 187,000. I either had to go to 180 or a 200. Which one should I go to? Well, it says I can't exceed the load. Should I really undersize? No, so they had to clarify it that says you can go to the next available size. Right, and then there, of course, you have the efficiencies of your equipment. Those efficiencies were updated in a lot of the tables, and then added a footnote in some of the tables for that you can't have a continuously burning pilot light. So that's the main there. For the main change here in your heating and cooling systems is really the title and the wording of the main parent section. So it clarifies that 403.4 is going to talk about all your heating and cooling controls. So it moved everything, reorganized everything into one section. You don't have to jump around to find the requirements. They're all right here. Then each of the subsections, the sections talking about all the different types of controls, really didn't change too much. Whether you think it's significant or not, the real change is where to go from the old language that said controls had to be capable to meet the requirement, that now it says they have to be configured to actually meet the requirement. So they have to actually do it and not just be capable of doing it. And then the other changes is that it clarified that these controls are mandatory. These are not something you can trade off. These are not something you can leave out. Controlling, we're not going to mess with mechanical equipment. That's the mechanical section of the code, the IMC. But what we are going to do is provide controls to shut it down when we don't need to use it as much. Sequence the operations. Do these things that have them have controls that can shut them down when they're not needed as much. A new thing that you're going to find in there is these controls, the vestibules. Vestibules have never, there's never been any mention of can you heat it or cool it or not. Now we're finding that a lot of people are heating or cooling their vestibule. And this is just saying they were never intended to be heated or cooling. They're this energy saving measure to keep this big, huge swoosh of air between the doors from opening. And it wasn't really meant to be heated or cooled, but people are doing it. Okay, you're going to do it? Fine. Then let me just tell you that now it says if you're going to heat it, you can't heat it past, it just puts limits on it. So if I heat it, you have to provide a control that shut off the heat when the air outside is more than 45 degrees. It's not saying you can't heat it, it just limits it. A thermostat has to be provided in the vestibule that limits the temperature to not greater than 60 degrees for heating and cooling to not less than 85 degrees. I'm not cooling this or heating this to human comfort. I'm just tempering the air a little bit so it's not a drastic change. And that's what it's trying to do. Part load control, so for those designs that call out hydronic system, the code used to have requirements for part load controls that they only kicked in if you had a system over 500,000 BTU. Now they kick in if you have a system over 300,000 BTU. There were requirements to automatically vary the fluid flow on hydronic systems if you had a motor capacity over 10 horsepower. Now it's if it's over 2 horsepower. So there were definitely some efficiencies changed there. Economizers, not a ton of changes in the economizer section other than the thing that I like, they put it all in one section. You used to have to jump around to find the requirements for air economizers, water economizers, all the different control requirements. Not anymore. They're just all in one section, 403.5 on it, so that's nice. Ventilation and exhaust, mostly just made the sections mandatory. Some of the significant changes that you'll find are going to be, the ventilation. They went through and put all of changed the language from configured or from capable to configured, and then added this thing that says, if you're bringing in some outdoor air and you're heating it, when you bring it in, don't heat it to more than 60 degrees. If you're trying to cool the building, why are you tempering it if you're trying to cool your building? And then if there are energy recovery requirements in certain situations, this just added more climate zones to that. Climate zone 7 and 8 really never really had energy recovery requirements, and now they've been added. Not saying that they're required in those climate zones under certain situations. And then one thing that you're going to find really new is this requirement for hotel rooms. So if I have a hotel room, it has to have some kind of control provided on the HVAC systems that's capable and that's configured to automatically raise the cooling set point and lower the heating by at least 4 degrees from the occupant set point within 30 minutes of the occupant leaving the room. Controls have to automatically raise the cooling set point to at least 80 degrees and heating to no more than 60 degrees if the room is unrented for more than 16 hours. So if I have people in the room and they leave and they're gone for more than 30 minutes, shut the system back a little bit, at least 4 degrees. If they're gone and you don't rent that room out for, a day or for at least overnight or more than 16 hours, then you need to set the cooling back to heating no more than 60 and cooling to no more than 80. So that's new. There are some exceptions in there, if you use different types of controls. So that's new to the 18. Fans, just change the title to reflect what it was really talking about. Fans, made it mandatory on the fans. Completely reworked the section and subsections on heat rejection, speed control, that kind of thing. Just the layout, not a lot of the requirements. Refrigeration equipment, this was condensed and brought in. So, we've had this requirement that walk-in coolers, freezers, refrigerator warehouses, these requirements came into the 2018. It's really about having a good thermal separation between the cooler and the rest of the space. Gasketed doors, good insulation, and that sort of thing, and efficient fans and motors. The change really in 2018 was to make it mandatory. It wasn't mandatory before. And then you have this, your duct systems. Make sure you seal everything up. Everything was made mandatory. Really, the only changes were because when you add more things in the code, your sections have to get renumbered and that sort of thing. So they had to update some code sections, but nothing really drastic in your duct systems. And then they reorganized this section for anything outside the building, heating outside the building. If you have radiant heat, your snow and ice melt systems, freeze protection, the requirements didn't change. They just all got put into this section called heating outside of the building. So your commissioning did change a little bit. So here's what I get people calling me and asking me, oh, I don't have to do commissioning anymore, because in the mechanical section, you were under the 15, I think it was like 403.2.11. It would say, thou shalt do commissioning in accordance with 408. Well, it doesn't say that anymore, so people think I don't have to commission. No, it's not that. It's just that they moved it. Right? So because commissioning applies to mechanical, lighting, and water heating, they just said in 401.2, right up front, in the very front of the chapter, where it says, here's the paths that are available to you. Under each of those paths, if you choose prescriptive or performance, whatever, you have to do commissioning. It tells you that up there. So that is moved up there. So don't think you don't have to do it. It adds a requirement for the commissioning reports to include, it used to just say, okay, here's the tests that we do. Now it says, oh, I probably should put the test results in there too. So you have the test procedures, you have the test results. It used to say you just give a commissioning report to the owner and give the letter to the code official, and now it says no, the code official gets a copy of the report. And it adds this commissioning checklist. So this checklist is actually a part of the code now that anybody doing the commissioning, whether it's a commissioning, the mechanical engineer, the registered design professional, commissioning agent, whoever's doing the commissioning, they all turn in the same report so that you have this standardized thing that you can look at when you're doing your inspections and plan review. So this checklist is actually in the code now for commissioning. When it comes to lighting, some changes, just clarifying that when you have dwelling units in apartment buildings, though you comply with the residential code, and then everything else can comply with the residential code or the commercial code, you have your choices. They brought in this new definition for luminaire light level controls because they brought in the option that you can use luminaire light level controls in lieu of occupancy sensors or time switches in certain places. So luminaire light level control is like this light level control that senses all of the light, not just the outside light, but the other lights in the space, and lets you keep the lights to a certain level. And so that is now an additional option in the code. Then they brought in requirements for open office spaces because these were left out in the code, just talking about these open office spaces. When should the light shut off, and how big can the space be that you can control under one light or one sensor or whatever, and allowing some minimal level of safety lighting while if these people aren't here but these people are, these shut off. And so it's there's some different requirements in there. There's some new provisions for open office lighting. And then there's a change in occupancy sensors. It used to say all occupancy sensors shut off within 30 minutes of people leaving the building. Now it's 20, or the space. Hotel, motel, sleeping units always used to say that lights, you have a switch when you walk in the door that turns on some fixtures. This was so that when you're walking out of the space, there's a switch by the door. You might shut it off, but if you got to go back and shut off a lamp and you got all your luggage in your hand, you're probably not going to do it. Well, now that's not in there. So now it says you either have a master device capable of automatically switching off all the installed lights within 20 minutes of the occupant leaving the room. So an occupancy sensor or some type of sensor that says you'll leave, or a card key device where the lights shut off when you take your room key out of it. Right? So when I leave the room, I'm going to need my key to get back in, so I'll take that key out. And so you have those options now. And then, with not a lot of lighting changes other than cranked down a little bit the watts per square foot for your occupancy. You are allowed less watts per square foot, whether you're using the building area method or the space by space method. Exterior lighting, the major change was we just don't call it tradable surfaces and non-tradable surfaces anymore. You have exterior lighting power allowance and additional lighting power. This additional lighting power is still not tradable. So, it's really the same. It's just the change of the name. And so your tables cranked down the wattages again, on some of this allowed outside. But this is your lighting power allowance that used to be your tradable. This is your individual lighting power allowance that used to be your non-tradable. It's still the same building areas and everything. It's just a different name. And lastly, I just want to, don't forget commissioning when it comes to lighting. It tells you right up front that lighting controls have to be commissioned. I need to know that this daylight sensor works with that occupancy sensor, works with that luminaire light level controller, that they all work together, that they're working, they're doing their job. They have to be functionally tested. They've always had to be since commissioning came in 2012. It's just that there was never a pointer to 408.3, so a lot of people weren't doing it, but it's always been in there. Occupancy sensors, time switches, daylight, they have to be functionally tested to make sure they work, and there has to be documentation of the results, and that if you go back and look at that commissioning checklist, there's a line item on there for occupant or for daylight controls, so don't forget that. All right, well, thank you. Again, I'm available to answer some questions. I think we're going to have questions right now, maybe.
That's right, Shaunna, we are. Thank you very much. I want to get right to them because I know that you have to get going at the top of the hour. So if we can start with a question from Pedro. He wanted to know, why are the commercial kitchen hood exhaust flow rates different in the mechanical and the energy codes?
Yeah, it's because we can never get the mechanical people to sit down in the same room with the energy people. I've always said that we need to lock them in the same room until they fight it out. If the energy code is going to conflict with any code, it's going to be the mechanical code, and that's unfortunate. We're working on it. We really are, and we have a group of us that are trying to work on that for the 2021. The mechanical code allows usually more than the energy code. The energy code is trying to save energy. And so usually they have to be capable of shutting down to this level, and not necessarily requiring a set level, but they have to be able to shut down to a certain level. But when it does come to hoods, it gets a little tricky, and I promise you we're working on it.
All right, I want to make sure people can get their questions into us. We'll do our best to try and get to them. We do have a series of questions from Ali, who is a code official. Okay. So here you are directly talking to a code official here, Ali, in Ali's name. The first question he has is, how does the energy code address blower door testing in existing buildings? And this is about a renovation. So at what point, what percentage of the renovation does it get triggered that you have to do a blower door test?
Isn't that fun, that existing building? So the 2015 and the 2018 have an existing building chapter that are in there. There wasn't a ton of changes to them. That's why I didn't bring them up. But so we have a huge working group right now that is going to rewrite that whole thing to make that to make the existing buildings chapter read more like the existing building code, where you have percentages and you have things so that it makes more sense. Right now, it's basically says, your building has to comply no matter what, almost all the time. And so how do you do that blower door? There are times, yes, some jurisdictions require you to do a blower door and some do not. But if you do a blower door on an existing building, I'm going to do a renovation or something, a lot of jurisdictions say do a blower door ahead of time and do one after, and just show that you didn't get it worse than it was. You didn't make things worse or whatever. Some jurisdictions don't make you do it at all, and some will say, put up plastic around the walls where you're not going to be touching, so that you're not considering those, and you're just doing a blower door against the wall that you're actually touching. There's different ways to do it. It's unfortunate that chapter is so, they just grabbed all of the stuff out of the other chapters and threw them into this one chapter, but we didn't take the time to write it in understandable language. I have 3 meetings tomorrow about arguments over what's written into that chapter 5. It's just not good written. I'm sorry, but we are rewriting the entire thing in 2021. Not that that helps you right now. It's hard to say. Every jurisdiction handles it differently. Right.
Well, and so to keep going with a couple of the questions from Ali, and he's in D.C., by the way. Mm-hmm. And he brings up the thing, again, existing buildings and specifically historic buildings where they have exposed brick walls. Mm-hmm. He's wanting to try and figure out how to encourage air tightness while preserving the historic features.
Right. So it says in there, right. So it says historic buildings don't have to comply as long as you can write a letter saying why compliance would affect the, degrade it, or, it has all this list of things. And so a lot of times historic buildings are exempt, but you do want to think about them. A lot of times you can't do too much about the brick walls or the masonry walls. You could put a coating on them so that they're not as permeable and still have the look. That's one way of doing it that I've seen done without really touching it, because once you touch it, boy, then you got to bring it up, right? And so the biggest thing that I've seen people do for air sealing of those existing walls to maintain the look is to put a coating on them. It does make them a little shinier than you might have wanted, but that's one way of air sealing.
Okay. And then the other question that he had was, so you got a 2-story house, and they're reconfiguring the interior space on the main level, but they're not exposing critical areas that need to be air sealed and meet the 3 ACH 50 in their climate zone, which is climate zone 4. But are they expected to increase their scope to expose and address top plates and sill plates and electrical outlets?
No, that is not the intent. So the intent, if you read in the chapters, it says, we want to get the best that we can without requiring you to, if you weren't going to touch it, you don't have to fix it, for the most part. The only time that really, really changes is if you're doing a change of occupancy. Change of occupancy says you have to bring up the building to in its entirety. But the rest is, if you don't touch it, you don't have to fix it, depending on the path you choose. Now, if you choose performance, the way it's written, it kind of got messed up. And so if you choose performance, you have to show, like if you're doing an addition, You have to show that your house will not use any more energy with the addition than it did without the addition. Well, then you might have to do something to the existing building, because, you know, anytime you add on square footage and you heat it or you light it or anything, you're going to use more energy. So that means you might have to touch the rest of the house. But it just depends on the path you choose. But the main intent is, if I go into a house and I start renovating it, I only have to fix what I touch.
Gotcha. Well, I know we're at the top of the hour, but I think, Shaunna, there's one question that I have to ask, because I think it's certainly appropriate given one of your answers earlier. You talked about how this is going to get fixed in the next code cycle. Mm-hmm. Share with us where and when are those code hearings going to be taking place? That way, I mean, because we've got an audience that's spread around the country from Washington, D.C. all the way up to the state of Hawaii right now. And so, you know, some of the people who are on here may want to participate in those hearings. And one of the things I really appreciate about the IECC hearings, but of which I've been a part of in the past, they are open to the public. They're free of charge. Anybody can participate. Right. And so for those who are on this webinar who may want to participate in that next code cycle, how do they do that?
Please do it. It's not may do it, but I feel it's our obligation to do it, especially those that have to use the code. We need to be more involved in writing it. You know, you can't, it's like complaining about the president if you didn't vote, right? You can't. If you want to say so in this code, take a part of it. It doesn't mean you have to be at the hearings. It'd be great if you can, but you can help write it without being there by, you know, working through groups. We have national collaboration groups all the time. So we're writing the 2021 right now. The hearings, you can't propose changes right now to Group A. That's the mechanical code, the plumbing code, and all that. All of those changes had to be submitted by January of this year. Have already gone to one committee hearing and are going to their final hearing in October in Virginia. That's the mechanical code, the fire code, the plumbing code, and some of those other codes. The residential plumbing, residential mechanical. Those are already in the process. You can be a part of it by voting if you're a voting member, and you can be part of that final hearing by testifying against something that might have already been proposed. And so you could still be a part of that. You just can't submit a new change. However, there's a Group B hearing that's heard in 2019. That's the energy code. That's the rest of the IRC. That's some more of the IBC. There's still parts of the IBC that aren't written. It takes a couple of years to write all of these codes. So we're writing the 2021 IECC right now. Changes have to be submitted to ICC by January of 2019. I think it's January 8th or something. You have to submit your proposals. Then those will all get published, and they will go to a hearing in April of 2019. That'll be the first hearing. They'll have a hearing in front of a committee. Then it'll go back out to the public to comment on again. Then it'll go to another hearing that the public gets to vote at, and then it goes back out to vote to the government officials online. So it's a long whole year process of writing this code. But if there's something in that 2018 you want to change, you have to submit that change before January. It's not hard, it's all online, it's easy to do, but if you don't know how to do it, contact me. I will help you walk through. If you can't make it to the hearings, I don't know I can't remember where the 2019 hearings, you can go to ICC, that's the International Code Council, who publishes the codes, ICC SAFE, SAFE.org, and look under code development and just click on current development cycle, and it'll give you when all of those hearings are and where they're located and what time you have to have proposals due and everything in there. ICCSAFE.org under code development, and click on the current development cycle. So if you want help writing a proposal, or you know of something you would love to see changed, call me, email me. Don't call me because I'm not at my phone very often, but email me and I am happy to help you through that process. We need more people that have to use the code writing the code. So please email me and I'll help you. If you can't go to the hearing, I have to go to the hearings. I'm going to be there. I'll testify for you. Even if I don't believe in it, I will testify for you. It'll be your words, right? Because you couldn't be there, and that's fine. I just want some more people to be involved. So, like I said, there's hearings in October in Virginia. Those are going to be on the mechanical, plumbing, fire, and some of the IBC. And then next year we'll start with the energy code.
And I've got some further information because I was able to look it up while you were talking, Shaunna. So yes, October 24th through 31. So happy Halloween! You will be at hearings in Richmond, Virginia, at the Greater Richmond Convention Center. The IECC, both commercial, residential, the IRC Energy Chapter, the IBC, all those will be heard at the Albuquerque Convention Center in Albuquerque, New Mexico, April 28th through May 8th. And then that's the committee action hearing. And then the public comment hearing will then wrap up October 23 through 30 in Clark County, Nevada.
Right. Perfect. So, I mean, go, and if you've never, even if you've never been to a hearing, they post them online live at iccsafe.org. So when October 24th comes around and you're not in Richmond, Virginia, you can be at your computer watching it online. And, they go sometimes from 7 in the morning until midnight. You probably don't want to do that. But if you watched an hour even, it's great to just see how these get written, how people write them, how the arguments are. You get 2 minutes to testify and then 2 minutes of rebuttal, and there's all this stuff. So you need to watch that to see how these codes get written and who's involved in them. It's a very good process. If you want to know the code letter by letter, go to the code hearings. Even if you don't have a proposal and you don't have any changes, watch the code hearings or go to the code hearings. That's where they pick apart every letter, every comma, everything about the code gets heard out. You hear why things go in, why things got taken out, why things didn't go in, and it helps you really understand the code.
I completely concur with Shaunna's words. And yeah, the webcast is something that they do. You can watch every moment of it if you want to. And you'll get a crash course in Robert's Rules of Order, too. So, well, Shaunna, I know we need to let you go so you can get back to the class that you're teaching, but we really, really appreciate you joining us today. Any final words from you?
No, I just say, this energy code, don't get mad at it. There are a lot of options. You just have to, if you don't know the options, holler. I'm happy to teach you some of the options. Don't just look at that one table. Soak in the whole code. Go to the code hearings. Listen to the code hearings so you can see why do we have blower doors. I would love to come on here one time and just do why blower doors even got in there. Here's why. There's some building science behind it. There's some things. So the best way to find that out, if you can't go to classes, is those hearings. And there are reasons we put them in there. We think about cost of construction when we put things in a code. We think about how much it's going to cost if we don't put something in the code. We think about durability of buildings and flexibility and innovation. There's all kinds of things we're thinking about, not just one little thing, every item that we put in the code. So get involved. I'd love to help you, and thanks a bunch for having me.
Well, I can't speak for Green Builder Media, but I can speak for myself, Shaunna. I certainly hope you come back. It has been quite a bit of fun to hang out with you for the past hour and hear your knowledge on this topic and to be able to dig in deeper to some of these things. And by the way, the summation you gave today was fantastic. For those who were attending, you can't get a more succinct summary of two very large and influential and important codes. This was really good. So I appreciate it, Shaunna.
Thank you very much.
I also want to say thank you to our audience. Thank you for sending in the questions, for attending. We had great attendance today, and obviously thank you to NV Energy for their sponsorship of this webinar series. We'll see you back here in 2 weeks. We're going to be talking about LEED version 4, interior design and construction, and our guest will be Elaine A. Now, I hope you'll join us on Thursday. That's June 21st and it'll be 2 p.m. Eastern Time. Until then, have a wonderful rest of your week, and for those fathers out there, happy Father's Day. Take care, everyone.